A very good day to our professor, Dr. Salahuddin. We are from Basic Econometrics, Group A, Group 8. Today we are going to present a topic about the effect of education achievement on income inequality. Before we start our presentations, I'm going to introduce my group members and I. I'm Sinigo, number metric is 281031, and I have two members with me, which are Anis Atira, number metric is 267794, and also Nurul Zarifa, number metric is 281135. I am going to present about the research background. Income inequality as an uneven distribution of income among populations. It is still a major problem since it affects human welfare. Income inequality exists in all countries across the world, with the main variables being the magnitude of the gap between the rich and the poor. Over the last 30 years, the income inequality between developed and developing nations has increased significantly. So Malaysia's Gini index was at 46.2% in 1989. However, it has since fallen to 40.7% in 2019. Malaysia's income inequality remains high compared to other Asian nations, but it is gradually decreasing. Level of education has a significant impact on an individual's earnings in the workforce. According to some researchers, income inequality was often linked to be directly related and be affected to education. The impact of education on income inequality has remained a difficult topic, and several studies were conducted in recent years. There was a mindset that held that educated workers have a competitiveness over unskilled workers. This showed that the higher one's degrees of education, the better one's chances of landing a well-paying job. However, because the theory of knowledge should indeed be appreciated and fairness was not completely applied in fact, it just made the community working. As a result, this aggregates unskilled labor to earn an undeserved incentive, resulting in increasing income inequality. Another opinion is that due to a lack of employment in Malaysia, highly educated individuals may be employed below their educational level. Therefore, the salary earned by such educated employees would not be equivalent with their educational level.
My name is Nurul Zarifa Miti Muhammad and my metric number is 281135. Next, I will explain about the problem statement. Inequality is bad for a society as it goes along with weaker social bonds between people, which in turn makes social problem more likely. It is a worry in practically every country throughout the world, and many individuals are imprisoned in poverty with little opportunities to move up the social ladder. The main purpose of this research is to identify the problem arising in the relationship between Gini index and government expenditure on education, expected years of schooling, GDP per capita. A number of empirical studies regarding Gini index has shown the positive effect between those variables.
Hi and Assalamualaikum. My name is Anis Atira binti Zana Abidin, metric number 267794. Okay, I will continue my part, which is the objective of the study. Okay, in the research, the main objective is to examine whether education will be the key variable to explain the income inequality in Malaysia. This study also focuses upon the relationship between income inequality and some of the factors that are responsible for decreasing or increasing the gap of income inequality by other independent variables such as government expenditure on education, expected years of schooling, and GDP per capita. Okay, next I will present about discussion of finding, which include descriptive analysis result. As we can see from the table above, shown the result of mean, median, maximum, and minimum value and standard deviation for each variable. Okay, Gini index has a mean of 44.810. The median is 44.825. Minimum and maximum value is 39.900 and 49.100, and its standard deviation of Gini index is 2.581. Okay, as compared between standard deviation and mean, the result shown this data located very far to the mean value. If we plot the equation line, all of the observations are everywhere to the regression line because the regression line measures the mean of variable. For government expenditure of education has a mean of 5.2 0.236 and median is 4.940. Obtained value for maximum and minimum are 3.595 and 7.658. This observation is located close to the mean value because its standard deviation is 0.957. If we plot the equation line, all of observations are close to the regression line. Okay, next. For the variable expected year of schooling, the data is close to the mean value of 12.107 because its standard deviation value is 1.307. If we plot the equation line, the observation will close to the regression line too. This median of variable expected year of schooling is 12.550. Its maximum and minimum value are 13.900 and 9.700 respectively. Mean, median, minimum and maximum value of variable GDP per capita is 6,580.212, 5,269.620, 2,441.740 and 11,414.21 respectively. From the result of standard deviation, which is 3,167.951 for GDP per capita, we can conclude that the data is located close to the mean value. If we plot the equation line, the observation that we obtain are close to the regression line. Okay, next is correlation analysis. Okay, based on the table shown, there is a positive correlation between Gini index and government expenditure on education, which is 0.076. This is considered a weak correlation. Meanwhile, for the expected year, schooling and GDP per capita both have a negative correlation, with the Gini index, which is 0.62 and 0.783. This can be considered as moderate correlation. Okay, next is multiple regression analysis. From the table, on average, if all independent variables are 0, then the predicted Gini index is 56.078. On average, holding expected year schooling and GDP per capita constant, if government expenditure on education increased by 1%, then the Gini index increased by 0.061%. On average, holding government expenditure on education and GDP per capita constant, if expected year schooling increased by 1 year, then the Gini index decreased by 0.753 years. On average, holding government expenditure on education and expected years schooling constant, if expected GDP increased by 1 USD, then the Gini index decreased by 0.0004 USD. Moreover, the probability of F statistic is equal to 0, so it indicates that the model is fit. P-value for all independent variables shows that it is more than, so we fail to reject. So the test is statistically insignificant at the level of significance. This means that 65.26% of the variation is in Gini index can be explained by government expenditure on education, expected years, schooling, and GDP per capita. For adjusted mean, that 61.25% of the variation can be explained by government expenditure on education, expected year schooling, and GDP per capita.
Next, we will do the diagnostic checking. The first one is normality test. This is the figure of normality test where the null hypothesis is normal distribution and alternative hypothesis is not normal distribution. As you can see from the figure, shows that the probability of Jacobera is 0.727, which is more than alpha 0.05, and the p-value of the JP statistic is sufficiently larger than the level of significance. Thus, the null hypothesis that the residuals are normally distributed cannot be rejected. Hence, mean value of residual, which is 5.12e minus 15, is nearly to 0. Second is autocorrelation. The first one is preliminary test. As you can see, the scatter diagram in the figure shows for Gini index T versus Gini index T minus 1 shows a concentration of observation in the northeast and southwest quadrants, an indication that they are positively correlated. Then, this is the result checking the correlogram of the series. As you can see, the picture shows that there are 6 flags: 0.858, 0.73, 0.38, 0.606, 0.435, 0.333, and 0.239, where the autocorrelation exceeds and outside the significant bound, which is 0.202, and its values is significantly different from 0 at a 5% significant level. So, we conclude that the errors are serially correlated and there is evidence of autocorrelation. Then, the second one is Lagrange multiplier test or LM test. The result shows p-value for F statistic and chi-square are 0.007 and 0.006, which is less than 0.05. So, this means that the test is statistically significant. A null hypothesis of null of no autocorrelation is rejected at a 5% significance level, and we conclude that autocorrelation problem exists. Next, this is the remedies for autocorrelation using autoregressive like model. From the first picture, the result shows that chi-square statistic is 0.522 and F value is 0.348, which are less than their critical values. Their corresponding p-values are 0.470 and 0.563, which are greater than alpha, which is 0.05. The test is statistically insignificant, so the error term is heteroscedastic. In conclusion, a null hypothesis of no autocorrelation is felt to be rejected at a 5% significance level. And the next picture shows that there are no lag and autocorrelation is not exist. It is reasonable to conclude that there is no serial autocorrelation.
Next, we also can choose Bruce-Pagan as the formal method of heteroscedasticity test. By using Bruce-Pagan, we can see that the value of chi-square statistic is 4.935 and the F value is 1.706, which is much less than their critical value. Their corresponding p-value are 0.177 and 0.190 respectively, which are greater than 0.05. So we fail to reject the null hypothesis of homoscedasticity at a 5% significant level. The test is statistically insignificant, so the error term is homoscedastic. As a result, we can conclude that this model is homoscedastic. Next, we also did for the multicollinearity test. It is said that if the central VIF exceeds 10, then those variables are said to be highly collinear. However, in this study, the VIF value of all variables are greater than 1 and less than 10, which is the VIF for government expenditure on education is 1.556. The VIF for expected years of schooling is 4.856, and also the VIF for GDP per capita is 5.023. So all the variables shows that a multicollinearity problem exists. Since the VIF value of all variables are less than 10, so the collinearity among variables are comparatively low.
So the conclusion of the study is the normality test to test the normality of residual. The result of this test proved that the residual is normally distributed with the shape of histogram does not skew to either left or right. It is concluded by p-value is higher than the level of significance, which is 5%, and zero mean value are close to 0. The LM test show that the p-value for F statistic and chi-square are less than significant level before doing the remedies. This result lead to autocorrelation problem, and after doing the remedies, the result show that no autocorrelation problem is exist. Furthermore, heteroscedasticity problem detection using Bruce-Pagan Godfrey also showing that there has no hetero at all. Lastly, the multicollinearity test, which is used to determine a linear relationship among variables, and the results show that multicollinearity problem does not show very serious problems since the value is less than 10. Last but not least, we also have found that there are several policies that can implement to reduce the income inequality problem in Malaysia. First is provide equal opportunity through education. When more employees have high skill level, wage disparity decrease. Similarly, when entrepreneurs from underprivileged background have the necessary skill and resources to thrive, it is less probable that high-paying jobs will always originate from from among the better off. Okay, next is increase the level of education. Nations with a better level of education and skill will have less wage inequality. Only 5% of young adults in the lowest income quintile hold a bachelor degree, compared to 40% in the highest income quintile. Furthermore, 84% of Malaysians with a bachelor degree are from the middle and higher class. This lends credence to the idea that has a greater level of education lead to a higher level of income. However, not everyone has the opportunity to seek a higher education. As a result, the government should work to make higher education as accessible as feasible while maintaining high quality standards. Furthermore, increase government wealth distribution efforts. Increased government spending on social expenditure has been shown to improve income inequality and poverty. Specifically, during the previous decade, the government has intensive wealth distribution incentive, which has had a favorable impact on Malaysian income inequality. Okay, that's all from our group. Thank you.